Here we want to graph the function h of x, which is equal to the square root of 49x. Okay, so first let's go ahead and graph it and then talk about the parent function for this. So we're going to create a table just to see what happens. So we have x as our inputs, and we have h of x, which is equal to the square root of 49x. And then we know that our ordered pair is going to be x, h of x. Remember that h of x is the same as the y coordinate. Now keep in mind here that all the values that we can pick for x cannot be negative. So they have to be either 0 or positive values. So the first one we're going to pick is 0. So if we plug in 0 into this function, we're going to get 49 times 0 and take the square root of that. 49 times 0 is 0, so therefore the square root of 0 is 0. So our first order pair is 0, 0. Okay, now the next factor that we want to pick is 1 over 49. So we're going to choose 1 over 49, and then we're going to plug it into this function. So we have 49 times 1 over 49, which is the same thing as 49 over 49, which is 1. And the square root of 1 is 1. So we're going to end up getting 1 over 49 for the x value, and the output is 1. Okay, now let's go ahead and pick another. In this case, let's pick a perfect square. Well, the perfect square after 0 is a 1. So now we're going to plug in 1 in for x. So we're going to have 49 times 1, and that gives us the square root of 49. And the number you have to square to get 49 is 7. So therefore this is 1 comma 7. Okay, now let's take a look at another value. Okay, let's say, what is another perfect square after 1? Well, we can choose another fraction. So let's choose another fraction where we have a perfect square. So we have a perfect square, which is 4 over 49. Okay, so what happens when we choose that value? So if we take 49 and multiply that by 4 over 49, well, that 49 divided by 49 gives us 1, so we have the square root of 4, which is going to equal 2. So 4 over 49 gives us an output of 2. Okay, and let's try the next perfect square after 1, which is 4. Okay, so the next number after 1 as a perfect square is 4. So 49 times 4 is going to give us the square root of 196. And what number do we have to square to get 196? Well, the answer is 14. So there are some ordered pairs that we can now plot for this graph. Now, let's figure out what numbers does represent 4 over 49 and 1 over 49. So we can simply go ahead and do that here. So 1 divided by 49 is about 0.02. Okay, and then what is 4 divided by 49? Well, that's about 0.08. So we can figure out, okay, where those ordered pairs are instead of fractions on our number line. So we know that from this is 1, this is 2, this is 3, and then this is 4, 5, 6, 7, and so on. And then here this goes from 0 to 2, 4, 6, 8, 10, and so on. Okay, so the first order pair that we have is 0, 0. Okay, the next one is 0.02, because this is the same thing as 0.02, comma 1. So at 0.02 you have 1. Okay, the next one we have for the fraction is 0.08, and that's 2. So we have 0.08, and then there is 2. Okay, and then we have 1, and then 7. Okay, so let me kind of move this over just a little bit there. So that's 0.8. Okay. And then we have 1, 7, and then we have 4, 14. So this is 10, 12, and then that's 14. So what's happening here is that we have the following graph. Okay, it looks like this graph is starting at 0, and it's going in that direction. Okay, so there is our graph. Okay, now the next thing that we want to do is now figure out what happens when we look at this graph on our answer. So we have h of x, which is equal to the square root of 49x. Okay, now because we're multiplying a constant by x, this constant is telling us that we're going to have a horizontal shrink. Okay, and that's by a factor of not 49, it's the reciprocal 1 over 49. Okay, and so the reason is that, let's take a look here. So if we look at our Desmos graph, okay, let's put in the square root function of x, because that's the parent function. Square root of x, there is our graph. Okay, now what we're going to do is we're going to take the square root of 49x. What's happening is that this is a horizontal shrink, okay, which means that this is shrinking. See, this is moving here slower, but this is a horizontal shrink. So let's take a look at our examples that we can choose from. So is it A? Is it B? Doesn't look like it's B. Doesn't look like it's D because it's going that direction. Doesn't look like it's C, so it looks like it's A. Let's check our answer, and there is our result.